Hi, today we're going to be looking at 5.1 Graphs of Reciprocal Functions. The learning goal for today is to sketch the graphs of reciprocals of linear and quadratic functions. And what that will do, it will provide insight of some of the features of graphs of rational functions that we will be seeing in future lessons. So let's begin, shall we? What we're going to do first of all is we're going to take a look at these two graphs. Here is the graph of y equals x, and here is the graph of the reciprocal of that graph, which is 1 over x. Okay, so what I want to do is we're going to take a look at the characteristics, certain characteristics of the line y equals x in this table. And after we take a look at some of those characteristics, then we're going to compare the graph of the reciprocal 1 over x and take a look at those characteristics and then start looking at some patterns. Okay, we're going to do this a couple times. So first of all, what we want to do is we want to take a look at the graph y equals x and see where there are zeros or vertical asymptotes. Well, as you can tell, there are no vertical asymptotes in this graph of y equals x. However, there is one zero here, and that would be at x equals 0. Okay, so now we want to look at the intervals on which the graph is above the x-axis. As I do a little switcheroo between graph and chart. So the graph here is above the x-axis when x is greater than 0. And I'll just write that in short form. I won't do the entire set notation for that. Now we want to look at the interval or intervals when the graph is below the x-axis. Well, that should be fairly straightforward for you to see that it's below the x-axis. Over on this side of the y-axis, so that would be when x is less than 0. Now we want to look at the graph and see on what interval or intervals is the graph increasing, or is the function increasing. Well, we see here that it looks like that from left to right the function is always increasing. So we can write that as it's the interval where it's increasing is from negative infinity to infinity. And of course round brackets because neither infinity nor negative infinity are included in that interval. Now if the graph is increasing from negative infinity to infinity, then obviously when we look at where the graph is decreasing, there would be no intervals where that occurs. So we say that there are none. Now we want to take a look at the point or points where the y value of the graph is 1. Well, we take a look here, we see where 1 is, which is right here. We come across and we see that that point is at 1, 1. So the point where the y value is 1 is 1, 1. And then if we want to see where the point where the graph is, or the y value is negative 1, we go to negative 1 and come across and we see that that is the point negative 1, negative 1. Okay, so we've done that for the line y equals x. Now what we want to do is we want to examine the graph of the line 1 over x, which is the reciprocal of x. So take a look at the other graph that's overlaid on top of the line y equals x and see where there are zeros or vertical asymptotes. Well, so now we're focusing on this graph here. So there are two branches of this graph, of that function, and we see that there are no zeros. However, there is one vertical asymptote, and that would be at x equals 0. We'll take a look at where the interval or intervals, where the graph is above the x-axis. And of course, while we're there, let's take a look at where the intervals, where the graph is below the x-axis. And so we see that the graph is above the x-axis along here where it's in the first quadrant, and the interval would be where x is greater than 0, and where the graph is below the x-axis is where x is less than 0. Okay, so we'll just add that in here as the camera focuses. And for the below the x-axis where x is less than 0. Starting to see a bit of a pattern here. Interesting. The interval on which the graph is increasing. Let's take a look at this now. So as we go from left to right along the graph, that doesn't actually look like it's increasing. It actually looks like it's decreasing. Okay, well maybe over here. Well, from left to right, again, the graph is decreasing. Okay, so for the reciprocal function, this graph is never increasing. So intervals in which the graph is increasing, there are none. Now let's take a look at where the intervals where the function is decreasing. And I see that it's decreasing for this left branch and is also decreasing as we go from left to right on this right branch. So it's always decreasing. Of course, there's a vertical asymptote at x equals 0, so that the graph doesn't actually exist there. So what we'll say for decreasing is that it decreases from negative infinity to 0. Neither of those endpoints are actually, well, that negative infinity is not even an endpoint, but neither of these boundaries of the interval are included in the graph, and also from 0 to negative infinity, and of course not included. Okay, and now we'll take a look where the y value is 1 and where the y value is negative 1. So take a look at this graph here. We see here's y equals 1, and we move across until we land on the reciprocal function, and it's actually this point 1, 1. And where we see where y equals negative 1, we move across until we see where it hits the reciprocal function, which is right here, and so that point right there is negative 1, negative 1. Okay, so now let's take a quick look just to see what kind of patterns have emerged here. So we see that zeros in our vertical asymptotes. The 0 for y equals x is at x equals 0, and the vertical asymptote for y equals 1 over x is x equals 0. The interval in which the graph is above the x-axis for y equals x is when x is greater than 0, and for the reciprocal function, again, where x is greater than 0. Intervals where the graph is below the x-axis, y equals x, is when x is less than 0, and for the reciprocal function, when x is also less than 0. Intervals in which the function is increasing for the line y equals x is from negative infinity to infinity, but the graph of the reciprocal function, there are no intervals where the graph is increasing. For the line y equals x, where the graph is decreasing, there are no intervals where the graph is decreasing, whereas for the reciprocal function, it's decreasing across the whole domain except for x equals 0, which is not included in the domain. So these seem to be sort of switched up here. And where the points where the y value is 1 is 1, 1 for both, and where the y value is negative 1 is negative 1, negative 1 for both. Okay, so we seem to have a fairly strong pattern here. The zeros or vertical asymptotes are the same. That makes sense, because you can't divide by 0. Hence we would get a vertical asymptote there. Where the graph is above the axis, it's the same interval. Where the graph is below the x-axis, the interval is the same. The points where the y value is 1 or -1, those points again are exactly the same. The only thing that's different is where the original function, the linear function y equals x, is increasing from -infinity to infinity. That's the same interval, or these two intervals, where the reciprocal function is decreasing, and then the original function y equals x never decreases, and the reciprocal function never increases. Okay, now we're going to move along to the second example.